Good morning to all. We are seeing the subject Cyber Physical System Framework. In this video, let us have introduction about the continuous time model of cyber physical systems. Let us first define what is meant by continuous time model. A model is said to be continuous time if the values of the variables of a dynamical system are updated continuously with the passage of time. So if any model is said to be continuous time, then the system has to be updated continuously instead of updating it at discrete instant of time. So that's the meaning of continuous time model. A model is said to be continuous time if the values of all its variables are updated continuously with the passage of time. Let us recall that a synchronous reactive component has some variables. Those variables are updated in a discrete logical rounds instead of continuous updates. So that is the difference between our synchronous reactive components and our continuous time model. Here the variables are updated continuously, whereas in synchronous components our variables are updated only at discrete logical rounds. Now let us see what is meant by continuous inputs and continuous outputs. So dealing with that continuous evolving inputs, we have a variable called signals. So we will be using the term called signals very frequently over here. So what is mean by signals? For a variable x, a signal over x is a function that assigns a real value to the variable x for every time t in time. We will denote such a function by x bar. Thus, x of 0 denotes the value of the variable x at time 0, and for every time t, x of t denotes the value at time t. So signal means we have a variable x, and this variable is going to get some values at every instant of time. Then we call that as a signal. How to represent the signal? Signal is represented by the term x bar. So x of 0 means the value of the variable x at time 0. X of t means value of the variable x at time t. So we call these as signals. Suppose we have a set V of variables. A signal V bar over V assigns values to all the variables in V as a function of time. So we don't have a single variable. What we have is now a set of variables V, and suppose this is having a signal V bar. So this is V bar over that variable called V. So what we have to do now is we have to assign values to all the variables in V as a function of time. So we have to assign continuous values to all the variables for which the set V has. For example, if the set V contains k number of variables, then a signal over V is a function from time domain, time to the k tuple or vectors. So this mapping we have to do from time domain to some other value. We have to do the mapping. That too we should have some real values. So if a set V contains k number of variables, we have to assign values to all the k variables. So the number k of the variable is called dimensionality of the signal. So when we have a variable that contains k number of set V that contains k number of variables, then that k is called dimensionality of the signal. That signal has that many number of dimensions. So alternatively, what we can say now is a k-dimensional signal can be viewed as a k-tuple of single-dimensional signals, one for each of the variables in V. So that is a vice versa of this. We have a set that contains k number of variables. We are going to assign values to all the k variables. That k is called as dimensionality of the signal. So we have a k dimensional signal means that can be viewed as a k tuple of single dimensional signals, one for each variables in V. So each and every dimension of a signal has one variable in V. So we have to know about this thing also. When we have two vectors, one is called u, other one is called v, and the norm of u minus v denotes the distance between u and v. And we will denote the distance of a vector u from the origin 0 by u. So when we have two vectors u and v, distance between them can be defined by this term, norm of u minus v. So in this video, we have seen the introduction about continuous time model. We'll discuss detail into that in our forthcoming video. Thank you.